Hello, everyone. Welcome, and thank you for joining us today for our webinar with guest speakers from NOAA's Ecological Effects of Sea Level Rise program. My name is Stephanie Simpson. I'm a program manager at Restore America's Estuaries. And on behalf of our presenters and all of our staff here at RAE, I'd like to thank you for joining us. Before we begin the presentation, I have just a few quick announcements. First, for sound quality, all participants will be in listen-only mode. If you're having any issues or technical problems, you can press *0 for operator assistance. Secondly, we are recording this session, so both the presentation and audio will be posted on our webpage, and we'll also share this link with all webinar registrants. And then finally, following the presentation, we will have a moderated Q&A. So at any point throughout the webinar, you can enter in a question into the question or chat box on your webinar panel on the webinar screen, and we'll work to answer as many as possible following the webinar. If we don't get to your question, you can email me or our speakers, and our contact info will be listed at the end of the webinar. So before we dive into the webinar topic, I'd like to provide a brief introduction to your webinar host and our speakers. Restore America's Estuaries is a national nonprofit dedicated to the protection and restoration of our bays and estuaries as essential natural resources. And in addition to providing resources like this webinar, we also lead an alliance of 10 conservation organizations across the U.S. coast and lead various national programs, including Living Shorelines, Blue Carbon, National Estuaries Week, and a biannual national summit. And our National Summit on Coastal and Estuarine Restoration and Management is the largest gathering of this community and will be held this year in Long Beach, California, December 8th to 13th. We're excited to host this 9th National Summit and to be on the West Coast again, and hope you'll join us. Registration is open, and we are still accepting poster abstracts. So with that plug, I'd like to go ahead and introduce you to our speakers today. Again, my name is Stephanie, and I work here at Restore America's Estuaries, and I'm really happy to have our two guest speakers today from NOAA's National Center for Coastal and Ocean Science, starting with Trevor Meckley. Trevor is an oceanographer at NCOS, where he manages projects for both the ecological effects of sea level rise and the Northern Gulf of Mexico ecosystem and hypoxia assessment programs. An ecologist by training, he received his PhD from Michigan State University while studying the invasive sea lamprey migration in the Great Lakes. And this gave him a foundation to guide his management of applied research programs that often offer support for the advancement of modeling methods to identify solutions to mitigate coastal flooding and nutrient pollution issues. And joining Trevor is David Kidwell. Dave is an oceanographer at NCOS, where he manages the Ecological Effects of Sea Level Rise research program. With over a decade of experience in managing coastal science projects, Dave promotes a collaborative science approach to produce actionable products and results. An ecologist by training, he received his MS in Marine, Estuarine, and Environmental Science from the University of Maryland. So thank you, Trevor and Dave, for joining us today. And with that, I'd like to go ahead and hand over controls to Trevor to start us off. Trevor?
All right. Can you see my screen all right?
I do.
All right, great. So thank you all for attending today. As you heard, we'll be talking about the Ecological Effects of Sea Level Rise program, or EESLR. We're located within NOAA's National Ocean Service and within NCOS, as you heard as well. So what we're going to do today, I'll talk a little bit about the program, and then we're going to spend most of the time just talking about projects that we think are relevant to managing coasts and managing estuaries in particular. I'll start off with focusing mostly on Gulf of Mexico project, and then Dave Kidwell will jump in later and talk about a number of other sites, including North Carolina, a couple sites in California, and then also in Hawaii. All right, so quick background on the EESLR. So EESLR really began in 2005, and we currently have 8 active projects around the U.S. If you see the red stars, those represent each of our project sites right now. And there's 3 kind of large-scale priorities for the program. One is advancing predictive tools and models that really predict inundation on the landscape in the future given sea level rise conditions. And we're focused on both inundations or flooding from storms or tides, high level tide and that kind of thing. Second objective is really evaluating the coastal community and ecosystem vulnerability to increased flooding because of sea level rise. And then finally, really a priority we spent a lot more time on lately is understanding what natural habitats and restoration projects that involve natural features provide in terms of both storm flood protection and also other benefits. So although those are our primary priorities, really what we see is the key to our program is a really collaborative engagement between funders, scientists, and stakeholders. We really make sure there's engagement across all three of those as projects are ongoing, and we lean heavily on that for setting priorities for our future funding opportunities. Our program requires really direct engagement between the scientists and those that are going to put that science into action on the landscape. And normally that comes in the form of management transition advisory groups, and those are actually involved at the proposal stage. So really at the proposal stage and for the entire project, there's people that are going to use that science engaged in helping guide the whole process. And it's really pretty amazing how a little tweak during the project that might get the scenario to be a little bit differently, or there might be a minor difference in the way the scientists go about something, and how much more valuable the output is at the end of the project. Whereas if you came in with that information at the end, there's just no good way to make that adjustment. So this is really an important piece and something you're going to hear kind of reiterated through the project is what role the stakeholders had in guiding things. So with that, I'm going to jump in to the first project. This is the Gulf of Mexico Research Project. The PIs of this work really got funding for a 6-year period between 2010 and 2016, and then were actually successful again in 2016, taking some of the models they developed even further. It's a really multidisciplinary group of engineers, biologists, ecologists, and social scientists, and that's often required to understand what the impacts are in the landscape of flooding, as well as really be able to value those things and understand what that means for things like marshes. So their focus is heavily on salt marsh and looking at what the health of salt marshes in the Gulf are going to be in the future, looking at what storm surge is going to look like in the future, and how natural features actually are providing protection, as well as helping understand how we can improve that ability. So first, I'm going to talk about the Marsh equilibrium model. So this is a product they took a little further during this project, and this is a one-dimensional model that predicts the health of marsh at basically a local site. So if you go to this link at the top, which you shouldn't do right now, but if you go to there afterwards, you can actually change all of the inputs to this model. Or if you don't know a lot about your local site, you can click on the buttons at the top that associate to Plum Island, North Inlet, South Carolina, Apalachicola, any of those sites, and it'll give you initial input data. So what's cool about this is you have the controls to actually change things like marsh elevation, the tidal amplitudes, whether or not you have a sediment supply from your river, any of those types of things, or the biological inputs, things like marsh growth. And now these are pretty detailed, so you might not have them, but it gives you a lot of controls. And the key is that you get this output graph. And what you have is elevation on the left side through time on the bottom. And the green line represents marsh, while the blue line represents water level. And what this is saying is when the green line drops below the blue line, your marsh is essentially drowned. In this case, it's around 30 years post the start of the scenario. And this allows for two things. One, just getting an idea of how stable your local marshes might be. And second, it might give you an idea of whether or not something like thin layer placement would be useful to you. You can essentially change your marsh elevation and see how much more time that gives you on your marsh to help make a decision about whether that's a realistic decision for you or not. Now, the Gulf Project took that tool a step further, and they actually coupled the Marsh equilibrium model with a hydrodynamic model called AdCirc. So that essentially allows you to spread the Marsh model across the landscape and understand what the impacts of currents and tides have on those marshes as well. There's a couple of pictures to the side there. One of the top pictures is a picture of a plug of marsh. There's in the bottom left is actually they're called small marsh organs, and the marsh organ allows you to look at marsh productivity at different water levels in the marsh. And the bottom right is one of the scientists, Kareem, taking elevation data. And I just wanted to highlight those three things because this model is pretty data intensive, but it really requires great marsh productivity information and elevation information because those are also outputs. And to have a good output, you need really good input. So the important aspects of this model that you can understand what the marsh vulnerability is into the future, how long it's likely to last across a regional type of perspective. Second, you're not just getting survival, but you're also getting the productivity. And then finally, it allows you to see where marshes are likely to migrate for important management decisions like land acquisition, or just understanding whether or not your reserve's in good shape. To talk about some of those takeaway messages and look at some of the patterns that we see with hydromem, I'm just going to take you through one scenario. So this is Weeks Bay National Estuary and Research Reserve, and there's three panels shown here. On the left side is a low sea level rise scenario, where it's only going to be an increase to 20 centimeters by 2100. In the middle is intermediate low, which is going to be a 50 centimeter increase in sea level rise by 2100. And then intermediate high is going to be a 1.2 meter increase by 2100. So that's intermediate high. You're going to see three different marsh colors show up, and that's low, red, medium productivity is green, and then a high productive healthy marsh is going to be that green color. So two things I want you to note is kind of the pattern you'll see of increasing marsh health and then an immediate collapse as you see things move. And second, the speed of the sea level rise is just really important to whether or not the marsh is going to survive. So at 2030, you see they all look pretty similar. There's a little bit more marsh on the coast, on the right side here, in the high scenario. But when you jump to 2050, you start to see some bigger differences. The low sea level rise scenario, not a whole lot changes. The intermediate low, you see a little bit of an increase in marsh on the coast and a little bit more productivity up in the watershed. And at the high, or the intermediate high, you see a little bit of ponding started to occur in the upper watershed, but also a lot of marsh forming and a lot of highly productive marsh on the coast. We often see a big change across the U.S. when we look at this model between 2050 and 2080 in these intermediate high and intermediate low scenarios. So again, the low sea level rise, not a lot's happened. In intermediate low, you see there's a lot of growth going on in the upper watershed, and in intermediate high, you see there's a good bit of ponding in the upper watershed. There's a lot of marsh migration occurring there. On the coast, you also see some ponding and some increased marsh migration, and that same pattern is going to happen at 2100. So you see, at those intermediate high and intermediate low scenarios, there's a lot of marsh migration occurring into the future, and that has some really important implications for parks, reserves, and protected lands where they have set boundaries. If the marsh migrates beyond them, they've just lost their protected land. So in this graph, this is the same site, looking at Weeks Bay, but in this case, we now have a 2-meter sea level rise by 2100, which is a higher scenario. On the graph to the left, you see acres of marsh, and on the bottom is through time. That black line, the upper line, shows the marsh for the whole region that you can see right now, the number of acres, and you see that it really goes up and then levels off around 2,500. But for the reserve, which is the green line in that graph, it's a lot different. You see it increases to a point, levels off, and then drops. And the reserve boundary is shown in that orange graph. So wherever that orange on the map shows up is reserve land. So I'm going to let this cycle through now, kind of try to remember where the reserve was along the river and around the upper shores, and then also on the coast. So around 2030, you see a lot of marsh forming. By 2050, you see that ponding starting to occur, especially when the reserve areas are. And by 2080 to 2100, a lot of stuff was drowning and migrating quickly. And that's what you see in the graph, is that around that 2075 period, there's really a lot of marsh loss. And that's definitely an issue we're seeing really across the Gulf, given our current expectations of sea level rise. So we do, as I mentioned, there's a couple other places we have this model now. On the East Coast, there's 4 sites in New Jersey, Plum Island, Massachusetts, Chesapeake Bay, and then also John Chase in Rhode Island. We also have this for Apalachicola, Florida, and Grand Bay in Mississippi. Now, I made that sound pretty gloom and doom. On the bright side, we aren't currently on that 2-meter sea level rise trajectory right now. So if we're able to reach a lower trajectory, which is hard to see if that's going to happen or not, but if given the lower trajectory we're on now, really there's a lot that can be done. There's a lot of restoration options. Marshes really are going to migrate a much slower rate if it's those lower levels. If it's the 2-meter level, we're in a lot of trouble, but luckily we're not currently looking at that stage. If we're able to help marshes keep up, there actually are some really important carbon storage implications. There's a lot of sediment trapped as the marshes need to try to grow on themselves to keep up. So there are some positive possibilities out there, but it just really depends how quickly our rates rise. All right, so that was kind of our Gulf Marsh portion. We're going to switch gears and talk about storm surge now. So this is the same team, and in that first project, they developed the NGOM3 model, which is a dynamic storm surge model. So most of the storm surge modeling that's been done in the past, they took the storm surge, they took the sea level rise increase estimate, and they just added that on top and said, if you had this level of storm surge, add the sea level rise amount, and that's probably what you'll see. Rather than that kind of approach, they went about it by actually incorporating the effective sea level rise on all of the processes that actually drive and affect storm surge in the models. So they have a much more dynamic and better representation that's more likely to really reflect what storm surge looks like in the future. So the model incorporates waves, tidal cycles, overland hydrology. It includes things like how embayments impact the way water moves along the coast. It includes coastal erosion processes and also biologicals through things like the marshes. Now, if any of the PIs are listening, I apologize because I just, skimmed over 5 to 10 years of their career. But I'm going to kind of jump into what they're doing with that model now, which is something we're really excited about and is really starting to come together. And the value is that you can actually include landscapes in this model. So you can run the model and you get a particular inundation of what the coast is going to look like under a storm surge or flooding event. You can then take a certain landscape, like you take away salt marsh and run it again, and you can find out what impact that salt marsh likely had on preventing flooding to that region. So they'll actually be able to do some real quantification of the value of natural habitats to protecting floods. So this is the kind of a flooding inundation map that you'd get. You can actually see how deep it was on the landscape and where the flooding occurred. What the team's doing is actually working with the HAZUS database. So the HAZUS database is census block information that by each census block, they've tabulated the value in terms of the commercial buildings that are on it, the residential, religious buildings, hospitals, all those types of things are tabulated by census block. They can overlay the water depth onto that and then estimate a proportion of how much of that block was damaged. It is averaged by block, but this is really a big step towards being able to understand differences between one flood and the next to make some real predictions. And here you see an example. So this is the kind of what a general building stock block would look like. You just overlay your inundation on it. You see in the little tab there where the inundation area was, and then you can estimate this amount of residential is likely to damage, this amount of commercial, industrial, agriculture, etc. They also consider religion, government, and educational buildings. So a pretty simple concept, but they can now use this modeling to look at what's the flood cost with and without a habitat feature and understand that immediate value, which is great. But there's a lot of restoration work going on in the Gulf right now, and there's really a big need to understand what types of restoration projects are going to provide a lot of flood protection. And we're hoping that this will also provide that. So this project won't be able to probably consider things that are like a very small living shoreline that's smaller than maybe a 10 to 100 meter stretch, but something of about that size or larger could probably be considered with this work. And we're working through exactly what scenarios would be considered. We're also considering some kind of more dynamic management advice. I'll give you one example of something we're doing now. So they're connecting their NGOM model with something called XBeach. They're working with USGS on this. The XBeach model is a barrier island morphology model and allows for, and basically predicts sand dune evolution through time. So you can really understand how the structure of sand dunes are affected by storms, and then you can also use the NGOM model to predict what type of damage or protection those dunes and barrier islands are providing. What this group specifically going to ask is what type of dune maintenance is most cost effective. So you can nourish in a lot of different ways. You can add sand just after storms, which is what's done often now. They wait for a big storm, it knocks out sand dunes, and they go in, they rebuild them entirely after those events. Or you can do something where you nourish post-storm plus on a schedule to ensure a certain level of sand dune protection is provided. And they can then estimate what are the costs of the damage plus the nourishment strategy and decide which one's better. A lot of other countries, like the Netherlands, use something that's more like the maintenance to guarantee protection, but the cost they receive from water getting through their dunes is maybe higher than it would be for a barrier island. So all these types of things can begin to be looked at, and hopefully we can provide a lot of important advice to the Gulf restoration over the next 5 to 10 years. All right, so with that, I am going to kick it over to Dave to talk a little bit more about dune morphology and dune management. All right, Dave, you should have it now.
All right, thanks, Trevor, and hopefully you're seeing my screen now.
I am.
Great. So, yeah, that's a great launching point, Trevor, for talking about some of the other projects that we're funding through EESLR. And what I'm going to do in this second half of the presentation is highlight one of those in slightly greater detail, which is this one you're seeing on the screen that's focused on dune recovery from storms. And then after this, I'm going to provide just some very brief vignettes of some of the other projects that we're funding, just to give you a flavor of the suite of projects and the types of outcomes and products that we're hoping to develop and are developing through our research funding. So this project here, this dune recovery from storms effort, is one that's been underway for about 3 years now, just under 3 years, and it's focused on coastal North Carolina. It's an effort that's run out of Oregon State University in collaboration with the University of North Carolina, Chapel Hill. And it really builds on years and even decades of work that those folks, those researchers have been doing on the beach environment, in dune environments, and looking to really advance the capacity from which we can understand how beaches and how dune systems recover after storms, which is obviously critical when it comes to a management or a restoration perspective, is understanding, at least through natural processes, what's going to happen to that landscape after storms. Because we've all seen the pictures of the highly scarped dunes and the completely eroded away beaches after storms, but it's what happens afterwards in the following years that there was a big question mark. And so this team has been tackling that for a number of years now, and in addition to that, looking at some of the underlying drivers of dune geomorphology, and then layering on top of that the implications of sea level rise and various management actions. So this is just a quick schematic, just as a reminder / primer on some of the key processes that are occurring on the beach and dune face environment during what would be considered a suite of conditions. And so you've got your normal swash conditions, which is your daily water moving up and down the beach face. Arguably one of the worst ones is collision, where perhaps a smaller storm is going by and it's really eroding away that face of that dune and oftentimes bringing that sediment offshore. One of the more beneficial, arguably, for dune systems is this overwash event, where you're getting net depositions. This is that classic Bear Island rollover processes that you most people are familiar with. And then obviously when the entire dune's inundated in a major storm, there can be some significant either net loss or even in some instances net gain for a sediment. And so this is the primary undercurrent from a processes perspective of what the team is looking at and what the model is trying to encapsulate or incorporate when it's trying to describe the recovery of these dune systems after storms. So this is really cartoon that describes in general what this model and what this tool is looking to do. And so Trevor, on his discussion of some of the applications of the storm surge modeling in the Gulf of Mexico, mentioned this X-Beach model, and that's a common platform that's being used in a number of areas around the country to look at various scenarios of Bear Island response to storms and various scenarios of restoration. So this team has taken that X-Beach model and coupled that with this Aeolus model, which is a wind transport model. So you can imagine when the wind's blowing, everybody, if you've been on the beach during one of these kind of windier days, you feel that sand blasting at your legs or your feet sometimes. And so trying to get a better understanding of how that sediment's moving via that process. And they couple those two with what's known as the coastal dune model. And this is one that really incorporates vegetative biophysical feedbacks, really focuses on the shape of the dune, how that evolves over time, what are the key forces that are driving that. And they brought all this together into this coupled model they're calling windsurf. And then this higher level effort of CREST, this coastal recovery from storms tool, is the package from which you can take windsurf and evaluate various scenarios and various climatic situations to understand what's going to happen on your beach. And so just some examples of things that you can do or will be able to do with this tool is look at various scenarios of plant species, beach nourishment, sand fencing. That's going to be a big one the team's going to tackle here in the next year, as well as these various scenarios of increasing storms, sea level rise, and other changes. One interesting aspect of this that I'm going to highlight on the next slide is that's the plant species component. And one of the theories that this team has been working on is that the biophysical feedbacks between the plant species that are on a given dune environment and how those dunes and how that beach face evolves over time is going to be dependent on the actual species. And this is based off some work they've done in the Pacific Northwest. That's what the diagram on the bottom right is indicating. These are several species of dune grasses that are found there that really are driving different shapes, whether they're taller, narrower dunes or shorter, wider dunes, or more hummocky, where you get this rolling pattern. And they're taking this theory and trying to test its application or how it holds up on the East Coast looking at the two dominant species in this area, which are the sea oats on the bottom left and the American beach grass on the top right. And for anybody that's been at the beach, particularly in the southeast of the Gulf of Mexico, those dunes are just covered in sea oats. And about the North Carolina area, that's about the northern extent of their range. And you see the slow transition to the American beach grass, which dominates as you get into the northeast. And there is some evidence that the range of the sea oats is expanding northward. And so there's potential application here for, or at least potential for this range expansion of sea oats having some implications for how the Bear Islands and dunes north of North Carolina might start looking into the future. In addition, species like American beach grass are really the common species that's planted when dunes are restored. You'll see pockets of it elsewhere outside of its quote-unquote normal range, and that's because it's been planted there purposely during a restoration event. And so, again, trying to get a better handle on, are there better species given a specific goal that you might want to plant, or what are some implications of these natural range shifts that we are seeing in these with these species? So the next slide I'm gonna look at is here, and this is an example of the output. And so I'm going to let this run a couple times because it's a bit nuanced, but as I walk you through what you're seeing here, but this is a example of what this windsurf and this CREST application will provide. And so the black line is the starting point of the beach face coming up to the dune, and then you've got the back dune area here. And then the colored line is what's happening over time. And right now we're getting about to the end of the cycle, and so I'll start it over again here in a minute. But what the simulation shows is an initial perturbation of a hurricane event really early on in the time cycle. You see a climatic representation of wave height and wind speed over time, with windier and rougher seas, typical at least on the East Coast during the winter months, and then calmer conditions during the summer months. And then based on this, we can look at over time. So here's the storm's going to hit. You see some initial scarping that occurs here. And then you can see what happens over time. again, we're getting to these winter months when the wave conditions are rougher. That scarping continues. It gets much more abrupt. You're losing some of your shore face. The dune height is getting taller because you're actually getting some sediment that's being deposited from that scarping event taking place up onto the dune. And then in the summer months, you're seeing the recovery. You can see that scarping becomes less dramatic. The shore face is recovering. The dune height comes down just a little bit. And what you'll end up with here, almost back at year one, is essentially a shoreline that's about the same place that was before the storm. You can see the scarp is still there, and that's certainly things that we've seen in the field. The dune height is a little taller than what it was just the starting point. And so you can see how these processes from a management perspective as well as from a vulnerability perspective, how these recovery processes can play out, because of a storm we're here to get now, that dune or that beach face is in a very different place than it was a year ago. But if there's 3 or 4 years, or if you provide some nourishment or some restoration to that dune, the situation moving forward is going to look very different. And so this was an idealized scenario. This was just an example. And so what the team is going to do moving forward is to do a comparative assessment between a highly managed beach system, which is on Bogue Banks, where you've got Atlantic Beach and other towns, huge tourism industry, lots of dune restoration, lots of sand fencing and plantings that occur to maintain those dunes, maintain those beaches for tourism value, protection value. They're going to compare that to a natural system like Cape Lookout National Seashore, which is not too far away, to see how the evolution of those two different systems will evolve over time and recover given various storm scenarios. They're going to, as I mentioned earlier, bring in the sand fence component. There's a lot of feeling that they may be both positive and negative when it comes to dune recovery and restoration, or at least there's some trade-offs associated with those. And so they're going to do a thorough analysis of the sand fencing as a management tool there on Bogue Banks, and then again the evaluation of the two dominant seagrass or dune grass species. And so those will be coming out in the next year. The tool itself is not unfortunately going to be one of these slick user-friendly interfaces where you can click buttons and turn things on and off. Just wasn't the resources. There just weren't the resources to do that, unfortunately. But the code itself for the model. So if you have some folks that are interested and are somewhat model savvy, or at least they know coding, we can provide that to you. It's going to be freely available. And so at least with some baseline expertise, at least that tool will be made available to folks. And hopefully in the future, we can make that interface a little more user-friendly with some additional resources. So now I'm going to jump into some of these vignettes of other projects and just give you a flavor, just a really, really quick taste of some of the other efforts that we're funding. Another one here in North Carolina. This one's focused on looking at the varying scenarios of marsh structure, orientation to waves, et cetera, on wave attenuation, trying to get a better quantification of the value that they're providing there. And this is a project that is also about 3 years in. They've been developing a modeling framework that can incorporate some of these key factors when it comes to wave attenuation to get a better handle on the relationships there. And so this project should be wrapping up within the next year or so as well, and we look forward to some of the modeling products coming out of that. I'm going to make a huge jump now all the way over to the Central Pacific Ocean to the Big Island of Hawaii, where we have a project with the Nature Conservancy who have been looking at some culturally and ecologically sensitive habitats on the Big Island, namely fish ponds, which are very unique, almost estuarine type environments on the island, as well as these anchialine pools where there are a host of endemic and or threatened species that are present. And these are areas right on the coast, and so there's been a lot of concern about the implications of sea level rise to these unique ecosystems. And so they've developed a tool to assist in that conservation planning and understanding what those effects are going to be under varying scenarios of sea level rise. This is part of their coastal resilience tools suite that they have online. And right now you can go online and you can find this application for the west side of Hawaii. And now the team is currently working on expanding this for the entirety of the island, at least in the key pockets. There's about 3 or 4 more areas of the Big Island where you can find some of these unique habitats. And so there'll be a link to this online app at the end of the presentation, and look for that to expand in coverage over the coming year. Going to move now to Southern California, where we've got a pair of related projects. This one is with University of California, Irvine, and really looking at this whole concept is there a better way that we can manage sediment in our watershed and in our estuaries and general systems and overall systems in general to have a better impact on our coastal ecosystems and our coastal environments. And so this team is looking at two very different watersheds. One is the Newport Bay watershed, where there's been for decades arguably very effective sediment management practices occurring in the watershed, so much so that there's some that say they've been too effective and that now some of the marsh systems in Newport Bay are becoming sediment starved. And so this team is looking to compare that type of system with something like Tijuana River, which is the other end of the spectrum with much of the watershed in Mexico. There has been a lot of rampant uncontrolled growth and development in the canyon lands in the Tijuana River watershed. That is, whenever it rains, essentially, that estuary gets completely inundated with a large amount of sediment. And so they've got a problem with too much sediment. And so this team is looking at various management scenarios and other implications of how you can approach these systems differently or better, let's say, that can have a net positive effect on the coastal environment and improve, at least from a natural perspective. That way you don't have to put thin layer placement or some other type of actual moving dirt. You can, in theory, let the system do the work for you once it's been managed more properly, arguably, for improving some of the ecosystems in these two watersheds. Related to this is a project we have, the State Coastal Conservancy in California, which is part of their much broader wetland recovery project. And so we're funding a fairly large collaborative effort with them and some academic institutions to look at essentially wetland and estuary restoration in the context of these intermittently open estuaries, and looking at scenarios of how sea level rise is going to affect the open enclosure of these. You can imagine from a ecological as well as a anthropogenic perspective. You know, we have some estuaries in Southern California that are always kept open. There are some that are allowed to open and close. There's a decision at times that's made to purposely open them because of either water quality issues or other concerns. And so looking at how sea level rise is going to affect these opens and closures from at least from a natural perspective, and then what the resultant effects inside that lagoon would be from an ecosystem perspective, and particularly from a wetland perspective, since that's really what this is a part of. And then related, because wetlands are so, at least in peril in Southern California, there's not many sites with large wetland expanses. Another part of this project is trying to look more into the future in terms of, okay, what are these transition zones? Where are these areas where we can perhaps facilitate wetland migration? Are there some things that we can do to install horizontal levees or other more hybrid approaches for natural systems to really facilitate this land migration? And so I was actually just at a meeting to discuss these transition zones and how they can be applied in various Southern California estuaries this week. And so this is a project that is really about halfway through overall. And so no big products yet coming out of it, but we anticipate some really cool stuff to help inform wetland restoration and management in Southern California from both projects that we have here moving forward. Last project I'll mention is actually not one that's included in the EESLR portfolio, but it's one that I include because I've been asked to manage it. And that's one that's funded through the Restore Science program in the Gulf of Mexico. And this one's fairly similar, at least conceptually, to the project in the Northern Gulf that Trevor highlighted, that's focused on understanding the role of natural features, natural systems, and storm protection, trying to better quantify the value and the benefits associated with that, as well as future vulnerability to sea level rise. And this project is not even a year underway. It's focused on Collier County in Southwest Florida, another area with increasing development pressures, but also some really unique ecosystems and mangrove systems that are located there. And so they've got some key products and tools that they're planning to come out with in the coming years to help with planning in this region. So certainly, if you're interested, let me know, and I can get you in touch with the project team out of the University of Florida. And this is one that we're looking forward to seeing mature in the coming years. So that's it from a project perspective, but I did want to highlight, because we thought it was useful, some additional programmatic. And so as Trevor mentioned, we do ask our projects to really have that strong connections to management. We do ask them to ensure that they've got ongoing. Before they even start the projects, these advisory groups that are helping to inform the work that they're doing. But at a programmatic level, so at our level here in NCOST and at the EESLR level, we are working with some internal folks, some internal scientists who've got some great geospatial product and tool skills to take a lot of these data products and take some of this information that we're getting from our projects and put them in a form that is better or that is effective for communication. And one we've been doing is story maps, and we have been finding these are really useful for not only communicating the type of information that is coming out of our projects, but also the tools and how to use them, et cetera, but also where you can find the data, where you can find some other information. And so we've got 2 of these that have been developed by our great NCOST colleague, Christine Buckle. Both of them so far have been focused on that Northern Gulf project, since that's the most mature. And I can provide some links to those 2 story maps at the end of this presentation. She's currently working on another story map, and hopefully this will be debuted actually next month in San Francisco at the Bay Delta Conference. And that's for the one project that I haven't highlighted here in these vignettes that we have with the U.S. Geological Survey in San Francisco Bay, looking at wetland vulnerability in the in North San Francisco Bay area, San Pablo Bay area, to sea level rise. Finally, last slide before we can take some questions. Just wanted to mention that we are planning another federal funding opportunity, hoping to fund projects or new suite of projects next year in fiscal year 2019. And we're hoping that the announcement for that, the call for proposals, if not September 2018, so next month, then hopefully by October that'll come out, and we'll be sure to get a wide broadcast of alerts and notifications when that's made available. We're also going to do some introductory webinars to get folks attuned to some of the specifics that we're looking for into that. So stay tuned for some additional information there. And with that, I will say thank you and look forward to answering any questions that you might have.
Great. Thank you so much, Dave and Trevor. That was a fantastic presentation. A lot of really great products coming out of EESLR. I do want to try to squeeze in as many questions as possible, so I'll go ahead and go through some of those. Since you just finished up with your presentation, I'll go to you first. Joseph asked, how many areas does the model cover, and what are the plans for expansion, if any? And he also added to that wanting to know what the language is for the model code.
Okay, so I'm going to assume that's referring to the dune project.
Right.
In terms of our funding, the model area is just going to be that the Southern Outer Banks area. We have been talking with the PIs because, again, they do a lot of work in the Pacific Northwest in other areas about possible application elsewhere, but there's nothing set on that yet. In terms of the model code itself, I believe it's in Python, but I'd have to get back to you on that to be 100% sure, and I can certainly follow up with you if you're interested. But I believe it's Python.
Great, thanks. I'll move to the next question. David asks, since salt marshes are essential fish habitat under the MS Sustainable Fisheries Act, how does marsh migration from sea level rise influence the productive capacity of salt marshes to support fish and shellfish harvesting?
Trevor, you want to tackle that one, or you want me to?
Oh, sure. So we're considering work that's being done on the fishery value of seagrass and salt marsh. Some barriers to really looking into that deeply is it's hard to get good data over large regions that really closely tie that value. Of course, if marshes are moving, there's certain species that are able to easily move to them, and that's not going to be a problem. In some cases, if the marsh is actually expanding in the amount of marsh there, it could be valuable. So the real trick is actually getting really good data that pair good fishery data on a salt marsh and then just off of it to really identify, locally what the value of the marsh is, and then expanding that across whatever region you have. And that's approach actually NIMS is taking right now in NOAA, and NOAA's National Marine Fisheries Service is working on some of that. We are hopeful that in relatively near term we'll have some data sets out there that can be leaned on, but it's a really difficult question to be able to ask marsh value in terms of fisheries across a very large region at all.
Great. Next question, I think it's also going to be for you, Trevor. Adam asked, are mainstream Chesapeake Bay sites going to be included? And I think he means in the model that you were presenting on sea level rise.
So what Chesapeake Bay sites?
He says mainstream Chesapeake Bay sites. If you know if Chesapeake Bay sites are included in the model at all.
Right. So if you look at if they look at that map that we had put up, this is going to be up, that'll show the full region. I think it's more on the coastal side. I don't think it's getting very much into the estuary. I don't know if Dave knows better than that.
Yeah, that effort was funded by the Fish and Wildlife Service, was focused on the outer coast, and does not include the main stem Chesapeake Bay, or at least any marshes in there.
Okay. Next question. Judith asks, since much marsh restoration in the Northeast and Mid-Atlantic involves removing Phragmites and planting Spartina, sometimes after lowering the marsh level, and since Phragmites can be a much better buffer, seeing that it's denser and taller, and it could enable a marsh to increase its elevation more rapidly, absorb more pollutants, including CO2, do you think that type of restoration makes sense in the time of sea level rise?
I can start with that. Yeah, so it actually is a pretty difficult question in terms of Phragmites may be much better at building elevation. There's certainly the negative sides of that. So it's probably in some ways a case-by-case basis of what you want to do. They're obviously moving to Spartina because of the other ecosystem benefits that are provided there. But it is a really difficult question that I know a lot of people are kind of grappling with.
Yeah, I'll just add to that. It's Sorry, I was just going to add to that. That's a tough question because those trade-offs are real, and I think from our perspective, although we don't have any projects that we're funding specifically right now in the Northeast looking at this, by some of our other projects where we're trying to get a better handle on what some of these specific wave attenuation values are based on certain characteristics of marshes. Now we can hope to try to get a better handle quantitatively in terms of understanding what some of those trade-offs are. It would probably require some additional research done on those Phragmite marshes, but I wouldn't want to have to make that call in terms of which one to go with. That's a tough one.
Right. Yes, really good question there. Our next question has to do more with seagrasses, which we didn't really mention much today. So Charles asked, what work is being done to evaluate the effect of future sea level rise on seagrass in the Gulf of Mexico and Southeast U.S., and how this varies with shoreline development, as hardened shorelines like seawalls would prevent landward migration, resulting in shrinking of seagrass areas as water levels rise?
Go ahead, Dave.
Yeah, so obviously we're not funding anything that's specifically looking at seagrasses. I know of some folks in Louisiana, at least off the top of my head, that are doing some work related to sea level rise and seagrasses. At least they were at some point. And so that's certainly an open research question that I think is worthwhile to look at. I will say you're 100% right on that. The hardening of shorelines and the loss of ability for those seagrasses to potentially migrate inland as water depths become greater in the coming decades. And so one of our overall goals, or at least underpinnings of in the past couple of years, where we've been trying to enhance this focus on these natural nature-based features in collaboration with some other federal agencies, is to try to provide the quantitative basis for not moving forward with bulkheads or hardened shorelines, to try to demonstrate where appropriate that these more natural systems can better or at least can equally as effectively protect the coast, but also gives you that ability as seas rise to be more adaptive and dynamic in their response to allow for not only the migration of the specific coastal habitat of a marsh or a mangrove, but also for those offshore habitats and those nearshore habitats like seagrass beds. And so it's a good question, and certainly one that I think highlights the interconnectedness and value of trying to move forward in this more natural approach that's going to be more adaptive as the coastline changes, whether we like it or not in the future.
Great, thanks for that. We've got time for a few more questions. So Sean asked, do any of the beach and dune models consider maritime forest communities or impacts to freshwater wetlands and dune systems?
Yeah, good question. The short answer is no. I should probably leave it at that, or I'll get in trouble in terms of saying something that I'm not exactly an expert on, because that's not my expertise, the maritime forest. But at least our project in North Carolina there is not specifically looking at that.
And kind of an add-on to that, anything on mangroves as a shoreline protection strategy?
Yes, that's a core component of that Restore Science project that I'm managing in Collier County, Southwest Florida. Is taking I didn't get into much detail on what they're going to be doing, but that conceptual approach to that dynamic feedback between water level and marshes that Trevor highlighted for wetlands, or at least coastal marshes, in that model called HydroMem. There's going to be a similar approach taken for mangroves, using a different application, the warmer model that's been used for wetlands on the West Coast by Thorne. She's on the project, and she's working with some of the hydrodynamic modelers in Florida to try to couple those two together to look at the dynamic response of mangroves to sea level rise into the future, and how those ecosystems are going to be evolving or not evolving or adapting into the future. So yeah, that's a really cool component of that project that I'm really looking forward to see how that plays out. Again, it's barely a year into its, I guess it's a 3-year project, probably closer to 4. So stay tuned on that one.
Great. We have another question from Kevin, who says that their current river elevation is several feet higher, and the river just isn't draining. So his question is, have you studied the effects of sea level rise on rivers with less drop, like the St. Johns River in Florida that only drops 25 feet its entire length, and the communities abutting the river?
Yeah, that's not been an explicit focal point for our projects, though certainly it's been a sort of a background feature. And I'd point to the work that was done in the northern Gulf of Mexico and in the Apalachicola area, because as you might suspect, that is very much a riverine dominated system where at least the lower parts of that estuary, they're very fresh because of how much freshwater riverine water is coming into the system. And it's like you described, a very low gradient environment. And so that was an underpinning of that project. I could get you some additional information on that if you'd like. Just send me an email. I don't know that it 100% addresses what you're looking at, but it might at least get you part of the way there.
Great, thanks. Let's see, we have kind of, I think I only just see one more, and Savannah asks, where can she go to find the story maps that you mentioned near the end? And to that, I think I'll just answer that we'll be sending out a list of links that were mentioned in this webinar to products. And Dave, I'm hoping we can include a link to the story map that you mentioned as well.
Absolutely.
And I do see one person mentioned that they had a problem with one of the links, so we'll make sure all the links are working when we send those out. So everyone, when we send out, look for that GoToWebinar email from us in the next couple of days that will include the link for the webinar recording and those products here. And also, if you do have future ideas for webinar topics, you can email me. So my email is also on the screen right now. I don't see any more questions at this time for the webinar topic, so we can go ahead and wrap it up. But I just want to say thank you very much to Trevor and Dave for an excellent webinar, excellent topic and products, and we're excited to share all those with you. And thank you all for joining us today.
Thanks, Stephanie.